There are two factors that keep the oceans and the air above the oceans cooler than the air above land. The first is evaporation, which cools the oceans also in equilibrium and keeps them cooler than the land. And the second factor is thermal inertia, which means that the oceans take some time to catch up with the warming during a phase of changing climate. It takes energy to evaporate water from the ocean surface and convert it into water vapor. This energy gets freed up again once the water vapor condenses into droplets in clouds and eventually falls as rain. But not all of that occurs above the ocean again. Some of it occurs above land, so that there is a water vapor transport from the ocean areas to the land areas, and that corresponds to an energy transport and therefore makes the lands warmer than the ocean. And as the climate warms up, this transport of water vapor from the ocean to the land areas increases, and therefore the land also warms up stronger than the ocean areas in a time of global warming. Thermal inertia is caused by the large heat capacity of the ocean waters. It just takes time to heat up water, just like a pot on the stove takes time to warm up. And most of the thermal inertia of the whole climate system is in the ocean. And that is why from the added energy that is coming from the increased greenhouse effect, more than 90% is going into the ocean, not because the ocean warms more strongly than the atmosphere, but because it just takes more energy to warm the ocean by 1 degree than it takes to warm the atmosphere by 1 degree. And this is why the ocean is lagging behind the warming of the atmosphere, especially the atmosphere above land areas. This difference between the land areas and the ocean areas is important because the ocean areas have actually warmed a lot less than the land areas of our planet. And so when we speak about having reached a global warming of 1.2 degrees up to now, it actually means that the land areas have already warmed up by nearly 2 degrees. And this is important to know if we're talking about limiting warming, say, to 1.5 degree or to 2 degrees, because where we actually live on land, that implies a warming that is typically 50% more or even twice as much as that global average number. The lagging effect means that the ocean is still catching up with warming after the greenhouse gas concentrations in the atmosphere are stabilized. Now, some people think that this means we already inevitably have passed the 1.5 degree limit because the ocean is gonna just heat up more. Luckily, that's not true because it only applies when we keep the greenhouse gases constant, but not if we reach zero emissions. Because when we reach zero emissions, there is a similar catching up of the ocean with taking up CO2 from the atmosphere as it is with taking up heat. And so with zero emissions of carbon dioxide, the CO2 concentration will start to slowly drop. And this balances out the thermal inertia and the catching up of the warming of the oceans. So that's good news. Bad news, of course, is the impact on marine ecosystems is going to get worse even when we reach zero emissions, because the heat is slowly penetrating deeper into the ocean and thereby changing the living conditions for creatures in the oceans, including the oxygen supply, etc.